So I'm Chris from Create Education. So I was a teacher for several years before starting with Create. I had a brief time, another 4 years in the automotive sector as well. I've been with Create now for probably just under about 5 years. When I was back teaching, I got my first introduction to 3D printing. Um, we had a tech department that were using a couple of the machines that we use on a regular basis, the kind of machines that here we've almost built our company around. And they weren't being used very much. So I started using those machines to make some resources for my chemistry classroom. And then it was kind of a little bit of a natural fit once I'd been out of education for 3, 4 years, and I started looking around for something different again. That this opportunity came up, and it was working with 3D printing, 3D scanning, etc., all of that kind of new technology, um, and work back with teachers, having a background in teaching. Create Education is what we call an Autodesk learning partner. So we are connected with Autodesk that way. We've worked with Autodesk for a long time, delivering a lot of training, but also it's our go-to design software for things that we would do in the kind of higher levels in the classroom, and in colleges and universities. It's industry standard software. We work with schools, colleges, universities, mainly to make sure that they're going along the right lines when they're looking at new equipment, to open doors to new pathways and qualifications, and to start teaching new skills. It helps that we are the sister company of quite a big industry focused company, 3D GBIRE. So they do all of the additive manufacturing, the 3D printing, 3D scanning and forming. Work with loads and loads of different brands of 3D printer and scanner and so on. But they only work with those companies like BAE Systems or Rolls-Royce, Airbus, Jaguar Land Rover, all the way down through to just individuals working at home with, let's say, an Etsy shop or something like that. You'll see loads of 3D printed stuff up on Etsy at the moment, and providing them with relevant kit. So because of the demands of what industry is asking for, we kind of almost piggyback off the back of what they do. We offer the same equipment that they do, but the mix of what we provide will be completely different because not everything that they use is suitable for use in a classroom. So we very much lean on our experience of how we've used that kit, or how possibly I've used that kit in the classroom before, to make sure that we're offering that advice to teachers and lecturers and researchers now. What we don't want to see is equipment sat there gathering dust. And in some cases, we can revive even old equipment like lathes and CNCs and all of that kind of stuff that we don't offer, but we offer very complementary equipment to work with. And then we do all of the support, all of the parts, all the materials, all of the training, and we do it very much from a teacher's perspective rather than just someone who's got, maybe come out of industry and been using that kind of kit and thinks they can go in and teach people how to use it, and so on. We do things in a very structured way, knowing what a teacher is going to have to do to present that to a room full of learners, that it's not that easy process, and the way that even we demonstrate it might not fit every learner and the way that they learn in that room. So there's multiple different ways a lecturer or a teacher can present that kit. So within biotech, the uses of 3D printing are massive. So just as a really straightforward example, I remember watching the news article during the pandemic about the team at Oxford that had come out with their vaccine. And in the background, they were showing there was a fume cupboard unit with an Ultimaker 3D printed unit on the inside that they were using for some of the tests that they were doing to create the vaccine. That was a really simple one that it's been used as almost like a custom jig or a fixture style unit that enabled them to be able to do something probably just a little bit quicker. some form of testing, even if that wasn't being used in the chemical test itself. Um, but a lot of parts that are needed to create new drugs, for example, we would do a lot of microfluidic parts and microfluidic chips. And traditionally, they're machined out of metal first, and then you make a mold over the top, and you flip that mold over, and you can use that mold several times to make a very small open-sided chip that you would run different compounds down and get them to mix together to form a new drug with controlled proportions of fluids in them. And instead of doing that and taking 2 or 3 weeks and thousands of pounds to manufacture a chip like that, we would just print the whole thing with enclosed channels. So you could have herringbone patterns down them and all kinds of things like that. Um, Another like more simple version of what we would do using our kind of standard desktop 3D printers is we could use MRI scans and X-rays to make simulations of patients' broken bones, for example, and print them out where they will be in place within a patient's limb, for example, so that a surgeon has a really good guide according to the scans of where all the bones are before surgery, and then be able to basically open the patient up and know exactly the route they were going to take to then put those bones back into the right place. Um, we can do casts for the outsides of broken bones. We've done that with one of our employees' children before, where we printed, instead of having a plaster cast, we've printed a cast that can be snapped open on a hinge and reclosed again, that was printed in material that's self-sterilized. So it wouldn't breed bacteria or viruses on the surface, because it would, over time, it contains copper nanoparticles, so it would kill bacteria and viruses on contact. There's a vast amount of different areas that we can go into, from the simple, these parts are kind of custom made to help with experiments, all the way through to functional parts used by patients, into the other side of surgical devices, um, things like trying to replace hypodermic needles by drug loading some of the materials that we actually make the parts out of, which would then kind of be like a little patch that would go into the patient's skin. The little needles would break off in the skin, and then they would be absorbed by the body, and that would contain a vaccination, for example, or some form of pain relief or something like that, that the body would then take on board. So yeah, all the way from the kind of experimental side all the way through to actually starting putting 3D printed parts into somebody's body. There is one more example that I had, that with 3D printed in titanium, um, replacement kneecaps. And that can actually be done really, really cheaply. It's currently done for patients that have replacement knees now. They might not realize it, but they will be 3D printed in titanium. And we we could actually do that relatively cheaply, quickly, very, very strongly. And each one would be custom to that patient, exactly an exact, you know, 0.01 degree of an angle replacement for their knee that's coming out. The kinds of skills that you'd need to really be someone who can take massive advantage of 3D printing are in the areas of design and application. There's so many different ways we can look at things when we can build something up layer by layer, and we can change the properties layer by layer as well, and change the materials throughout that part. That being able to almost take a step back and analyze what you're looking at from a different point of view, from a design point of view, from a function point of view, it really opens up a lot of different options. There would be, for example, in a lot of cases, existing parts that would be traditionally machines that would do a job, whether that's something like a bracket or a tube, which whatever it might be. But it takes kind of a different mindset to bring 3D printing into that. So instead of just replacing a traditional part for exactly the same part that's 3D printed, there are different things you can do with that 3D printed part. So a lot of the time we would have a look at maybe something that was machined out of aluminium and think, no, actually we can make that part by looking at the stresses it's under, it doesn't need to be aluminium. It could be a really high strength polymer instead. Does it need to be solid? Yes or no? Does it actually need to be that shape? If we have the software that can simulate the way that stresses are going to move through that part, maybe we could use a more organic structure that distributes the stresses through that part instead, and use far less material. We have to kind of look at the way that something's made and look at the job that it's doing. And potentially, even if you've got a structure in the middle that's holding two other structures together, we can look at doing all of that in one go instead of needing to keep doing separate little parts that join together. Um, Being able to look at the way that we use materials is a really important one, and analyzing not just why we are putting a part into a product or into a machine or something like that that is made that way because it's always been that way, and it needs to be made out of that. But looking at why and seeing, are there any other materials that we could use that may actually do a better job, um, and take advantage of the way that we 3D print them to put different structures inside those parts. It will take a different skew on the way that they think. They won't just be able to look at, the traditional let's solve the problem by making this. You'll have to have a look at it, step back, give it a bit of time and a bit of space, and look at the tools that are available. I know that they'll have different 3D printers and different 3D scanners and that kind of thing, and different software that they can use. Um, but it's having a look at the tools that are included with that, and not necessarily just jumping down the newest tech kind of routes and the fanciest materials and the generative design and all of those kinds of high end tools. It might be something quite simple, if they take the time and just step back and look at it. The challenges we would face in the UK versus a lot of the countries around Europe um, would be, different for education and for industry. So some that affect both would be budgets first, because a lot of the equipment, although it is coming down massively in price, we can do a lot more for the money that we used to be able to 3, 4, 5 years ago. Um, we need to be able to have the kit that fits in with the education side, that fits with the teachers, the staff, that they can use, but also fits in with their budgets and has longevity, so that they can then demonstrate those skills that students learn and can carry through into the higher end kit that might be going into industry. Another one would be the skills themselves. So, not just the skills on the students and the learners, but the skills on the staff, both in an education environment and in the working environment as well. Because we've got a lot of people in, let's say, in the engineering workforce now that would predominantly be the users of 3D printing. Um, we have a lot of those workers within engineering retiring now and not enough students replacing them. So you often hear the skills gap mentioned in industry, whether that's in engineering or even in biotech actually as well, because a lot of engineering and biotechnology there's quite a large crossover section that we work with. Um, and within the industrial side of things, there is an incumbent aging workforce, although I hate to say it, that sometimes is quite resistant to change. And the way that they did that product 40 years ago and the way that they made it 30, 40 years ago is still the right way. And they don't want to change that. And we actually see that within engineering in colleges as well, that a lot of staff would actually be ex of industry and they want to come in and teach how they taught or how they learned whilst they were in industry. But 5 years in engineering education is a very long time for a lot of changes to come through. And the way that industry 4 or 4.1, 4.2, whichever level you want to call it these days, a lot of that industry 4 technology has come into colleges very, very rapidly. And the students are actually very, very willing to learn about that new digital side, of that higher tech version of the way that they work, whether they're working with metals or whatever it is. Um, and we need the skills of the lecturers and the teachers to keep up. So I think there's an element of time for those teachers and lecturers to learn those new skills, um, and practice them before they have to put them in front of students, um, but also the budget that enables them to do that at the same time. So that's something that countries like the Netherlands, Germany, and actually Ireland now are putting a lot of time and effort into. Um, and that's something that the UK really needs to catch up with. We know from our manufacturer partners that are making the machines that some of their biggest markets are over in Germany and France and so on. Um, and one of the reasons is that within education there, they have to get to grips with this equipment because they can see what's going to happen in the future with manufacturing and how much easier it makes some processes. It's not going to help with everything. It's not going to replace all processes, but it's a very, very complementary process that speeds up a lot of different applications across industry. And they're switched on at the moment and they have the investment there to be able to go out and pick the right equipment, spend the time learning about it. And that's something that, while the UK isn't necessarily that far behind, it has got a bit of catching up to do. Create education would help by giving those students and their lecturers access to the new equipment and the technology that they're likely going to come up against. We have run some training sessions for some of the Leon team. And again, whilst it's not necessarily directly the kit that they will be using in Leon, because I found out they're using some quite expensive, very nice kit, which you wouldn't necessarily expect a college to have on hand, the skills that we've taught them apply almost exactly the same way to the kit that they will be using as the kit that we've taught them on. And that's exactly how it's going to work in industry. As part of what we do with World Skills, I'll be going around the country and doing demonstrations for both students and for lecturers as well, for different groups, um, at different, hopefully, key areas around the country, so that those that are interested can get some hands-on time with the kit. It will be kit that I can carry around, so it's not necessarily all the biggest kit, but it will be a really good demonstration, with a lot of surrounding information as well about how it's being used in industry and where those starter skills of the desktop 3D printer and the handheld 3D scanner and the little desktop pressure former and all of those things, how they work together and how they work in industry. And once you've learned those pathways and how they work together with each other and hand in hand with computer aided design and with other skills within manufacturing, how those go together to make things in manufacturing and engineering a lot easier. Um, so I can come round and give all of that kind of examples and case studies and all of those kinds of things, offer advice on what might be worth looking at and what's not. We know that as it's an emerging industry at the moment still, even though it's been emerging for 41 years, that there's a lot of there's a lot of hype. There's a lot of very strong marketing. There's a lot of really well-known brands out there within the sector that might not necessarily be the best thing for a college or a primary school or a researcher to lay their hands on, because it might be restrictive. It might not work best for everybody. And it might be massively overpriced, for example, for the skills that you need to learn. We could have something that's far, far cheaper and does the same kind of thing. So what we're trying to do is save the education sector, hopefully, a lot of money while still giving them a lot of value for the skills that those learners are going to take away. We would like to start as early as possible because there are projects that we would do with primary school children, for example. So little ways that we can use the 3D printing kit within English, within literacy, within mathematics. We don't want it pigeonholed just into, let's say, design and technology, for example, because one of the projects we would do is with some, let's say, 6 and 7 year olds, where they would design their own story dice by picking emojis that they identify with. And they would then put those emojis on a dice in Tinkercad or similar kind of software, even on the Purple Brick software, for example. That's got kit in there that we can teach 3D printing with, and students can learn how to use it from a very very young age. Um, would be surprised that I still see students in colleges that have never touched a 3D printer before, when there's other students that are learning about it when they're 6, 7, 8 years old. But when those students do get their hands on that technology early, they develop those skills really early on because they can see very easily how the next step goes and how the next step goes and how the next step goes. So they can learn from their early failures once they start trying to print things or trying to scan things, how that works and how they can do it next time. And how, as they move from single extrusion desktop printer to dual extrusion and up and start using bigger and better and metal machines and micro machines, the skills are the same. It's just how they apply them with different materials and at a different size and at a different scale. My advice to the team would be to get as much information as they can on what they're going to use before they go, and reach out to the manufacturer. I've already had a couple of people reach out to me to ask about the kit, and it is the kind of kit that we would sell, but not normally to a college. But we have contacts that work at the company that makes that equipment. And I'm hoping that they'll be able to link together and have a demonstration, maybe even get some hands-on time before they go to Leon, so they can see how they can apply their skills to that piece of hardware. Um, if they can do that with each of the manufacturers and the software suites that they're likely to use before they get there, that's going to be massively advantageous.